Yeah. Okay. All right. So if we bond one carbon to another, then we've clearly got an organic compound. Methane's an exception. It's organic even though it doesn't have one carbon bonded to another. Okay. So we can share this one. I can put another hydrogen here. And this is a subcategory actually of organic. And one of the reasons why we have methane in the organic category is that generally hydrocarbons are all considered organic. If we left methane out of it, then it would be kind of an exception to the exception again. So we have, problems. All right. So here, between the carbons, though, the critical thing is there's two carbons that are sharing electrons. It's covalent. So if we want to do our Lewis dot formula, so this is the sharing arrangement. We started with electron dot formulas, and then we did the sharing arrangement, and we showed the circles to share it. Now we're squeezing the electrons in between. It's a Lewis dot formula, and now I'm going to replace the shared electrons with lines. Each shared pair can be replaced with a line, and then we've got a Lewis formula. And we're beginning to learn about the Lewis formulas become a structural formula. A Lewis formula becomes a structural formula. We'll learn a lot about that in this unit. Okay? A structural formula actually shows how elements are put together. Not just that we have these elements bonded together, but the way they're put together. Okay? So this is the simplest of all the structural formulas. We're going to have a lot of structural formulas in this unit later. Okay. So what we have then are two carbons that are bonded together covalently. This is an organic compound. Then we have prefixes that we use for organic compounds, but these prefixes don't tell you how much of each element you have. These prefixes only tell you how many carbons there are. Okay? In organic chemistry, the prefixes tell you how many carbons there are. Well, one of the prefixes, the main prefix on what we'll call later the parent name. So if we have one carbon, that prefix is meth, like in methane, one carbon. Okay? And if we have two carbons like this, the prefix is eth. And if we have three carbons, that's prop. And four carbons is bute. Like propane, yeah. And like butane, correct. So this is the stuff you burn on your gas grill, and this is the stuff in the lighter that sets the gas grill on fire. Propane and butane. Okay? What is ethane used for? Not much.
Where does ethanol get are we going to talk about the ending for ethanol?
Yeah, we'll get to that. An OL ending means it's an alcohol. All right. Now, after 4, then the prefixes are very similar to the other covalent names. Okay? Only we're using this to name the number of carbons in the chain, not the total number of any atom. Okay? So after bute, then we have pent, which is 5, like the pentagon. Okay? Then we got hex. Okay? That's like what witches do on Halloween. No, it means 6.
What? Which is hex?
You with me over there?
You said a good one? I don't think so. Wait, hex is
Oct is like an octopus has 8 tentacles. Tentacles.
So they're kind of going back to normal.
What? Yeah, I said after 4, they're kind of the same. See, if you're listening, you know this stuff.
Is there a non-name?
What?
Is there a non-name?
Yes.
Can it burn?
Yes.
Is it fun? Fluid?
I don't know. I've never burned any non-name, but I assume it burns like most fuels. Octane is like the primary basic chemical in a mixture we call gasoline, in a solution we call gasoline. And so when you go and pump gasoline in your car and it has 97 or 87 on the pump, That's an octane rating. And then dec, like a decade, means 10.
Is the correct name for gasoline or petrol?
Both are correct. Depends on where you are. In the United States, it's gasoline. In most of the rest of the world, English-speaking world, it's petrol.
No. It would be different.
What?
So there would be different.
Oh, yeah. Well, it's like
They call
there's two common names for aluminum. In the United States, we call it aluminum. The rest of the world calls it aluminium.
Aluminum,
but who's right and who's wrong?
and we have inches.
I don't have a clue.
We're in America.
Yeah, good point, we are in America.
Okay? I'm not going there. I'm recording this, you know.
Oh, sorry.
If I say one, certain people will be upset. If I say the other, some people will be upset. You know, it doesn't really matter to me, honestly, on that. Okay? Just it's different ways of doing things. Okay? In the United States, we call the door that covers the engine in your engine compartment in your car a hood. Right?
Right.
Yes.
What do they call it in Britain?
A butt.
A bonnet.
I suppose.
Okay. All right. Huh?
A bonnet?
A bonnet. All right, let's move on.
I'm going to go off on a limb here and say that hood is
If you're in America.
I don't want to call it hood.
All right. So the only reason I'm introducing, listen please, the only reason I'm even introducing this at this point is because I want you to know that these prefixes will be used again, but in a different context. And you need to keep them straight. All right? You need to know where they're used and how they're used. Now, we call methane A-N-E. When we have an A-N-E suffix, that's actually going to be indicating there's all single bonds. Okay? So this is going to be called ethane, all single bonds between the carbons. Okay? Double bonds are ene. And triple bonds are ein.
No, still called it.
What?
I called it.
All right, let's talk about acids now. Non-organic acids. Please quit talking. Non-organic acids.
I don't know what it is.
So is this a different section?
Yes. All right, so we have, let's see, one, two, I guess you could say three different categories of acids. Okay, you've got binary non-organic acids, you've got oxyacids, and you have organic acids. We'll save organic acids for later when we do the organic chemistry section, okay, in this unit. All right? Right now we're just going to name binary acids and those acids that have oxygen in them. Okay? So let's start with binary acids. Let me give you a quick definition or some information about acids, not so much a definition. We have a whole unit on acid and base theory later in the semester. Right now we're just going to do some simple naming. Acids are acids because they behave in a way that puts, in the simplest way of thinking about it, hydrogen ions in solution. Okay? Acids are acids because, in the simplest way of thinking about it, we're putting hydrogen ions in solution. Yes? Okay? So let's see. Homework then. You've got 3 worksheets. Let's do at least 5 compounds on each worksheet. Okay? Huh? So you've got a binary covalent compounds. You have to name 5 on. All right. Binary ionic compounds you need to name. Actually, I've got 2 columns there, so let's name 3 in each column. All right. And then we got the acids table. Let's see. I need to get some more complex acids in there. I haven't named those, and since we got her leaving early, let's just check off 5 to do. How about that? We will do, since this one's done for you, I want you to do this one here for homework. Let's do this one for homework. We're going to do, let's see, if I do every other one. 1, 2, yeah. Okay, but we can do this. We can do 5, but do every other one, starting with the second one. Okay? All right. You're cool. I got you. All right. Didn't want to assign that early, but that's okay. We will manage to struggle through.
Can you show that again?
So the first one's done for you here on the acids. Okay, this one's done for you. Starting with this one, you're going to do every other one until you get to 5. Okay? What? All right, hang on a minute, and we'll go through all this again. Again and again.
The first 3.
Gracious, gracious. Gracious, gracious. All right. So because we have 2 columns here, we're going to do the first 3 on this one. Okay. This is the binary ionic compounds. Binary covalent compounds, we'll do 5 of those. All right. Did I leave off a worksheet or we covered them all? That's 3 worksheets, right?
Where's the worksheet at?
What now?
Where's the worksheet at? I don't have that one.
We've got 3 worksheets. One is formula writing and naming non-organic physical acids.
Right?
Okay? Formula writing for binary covalent compounds that are not organic.
I don't have that one.
Okay? That you don't have that? You do not have that one?
No.
Okay? And then we got one formula writing for binary ionic compounds. So you're missing the one.
And the second one.
Say again?
What's the last one you just said? Yeah, I don't have that one.
Those are the ones we have. Got it so far?
No, I just have the first one and the last one. I don't have the middle one.
So you need binary covalent compounds that are not organic.
Yes, sir. Sorry.
That's okay. You need to know what they are. It's good. There you go. All right, everybody got that written down?
Accidentally trip and fall into the door and pass out.
Yeah, just say and pass out.
And then he told us to do Caesar's one. Really? No,
That'll be you, Brian.
Somebody made it down.
Yep, I'm passing out one more handout here. You wanna make sure we get one All right, everybody got the homework done? Figured out what they're doing? So I'm passing out one more handout right now by special request. Okay, and we're going to do, this one also has a double column, so we'll do 6 of those. The first 3 in each column, okay?
Oh, okay. I thought you meant 6 and 10.
No, the first 3 in each column. 6 total.
Wow.
All right. And this is the stock system, okay, which is just another category under the ionic compounds.